All right, let's just dive right into this explainer. Today we're taking a look at a really fascinating path. We're going from the massive, tangible physical systems that literally power our everyday lives, all the way to the invisible digital trackers that are constantly monitoring it all in the background. And then we'll look at the human talent needed to keep this whole shebang running. It's a massive story of scale and interconnectivity, so let's get into it.
Here's our roadmap for today. We'll start with global oil choke points, then look at coal and natural gas. From there, we pivot to the hidden digital footprint, emerging STEM careers, and finally, the blended skills you'll need for tomorrow.
Section 1. Global oil choke points. We're looking at the sheer physical scale of energy movement.
Now check out this staggering number, 73 million. That is the number of barrels of oil squeezing through a few narrow maritime choke points every single day. This represents the vast majority of all globally traded seaborne oil for the first half of 2025. I mean, just think about the sheer logistical weight of moving 73 million barrels daily through such incredibly tight, geographically constrained corridors. It's wild.
And here's why that matters. Over half of the world's maritime oil trade is passing through just two narrow channels, the Strait of Malacca and the Strait of Hormuz. The Strait of Malacca alone is handling roughly 23.2 million barrels a day, basically serving as the main artery connecting the Indian Ocean to the South China Sea. Meanwhile, you've got the Strait of Hormuz handling about 20.9 million barrels daily. That's literally 1/5 of all global oil consumption right there. And get this, 84% of the crude oil moving through Hormuz is heading straight for Asian markets, like China, India, Japan, and South Korea. It really just goes to show how vital and honestly how potentially vulnerable these physical global systems truly are.
Moving on to Section 2, coal and natural gas. Let's look at the global and national leaders in consumption and production.
So the crucial takeaway here is just the absolute dominance of Asia in global coal consumption. Global coal demand hit yet another record high in 2025, reaching 166 exajoules. And China? China is by far the world's largest consumer. They're using more than the rest of the entire world combined at 55.6%. India is sitting in second place. When you put them together, these two rapidly industrializing nations account for almost 70% of the world's coal consumption. Meanwhile, the United States comes in third at 5.3%, where coal actually saw a recent 10% bump in usage, mostly just due to shifting natural gas prices.
Speaking of natural gas, if we zoom in on the United States, we see another incredible geographic concentration. The U.S. withdrew a massive 47.7 trillion cubic feet of natural gas in 2025. But here's the kicker. Nearly 45% of that staggering output comes from just two states. You've got Texas pulling from the Permian Basin at 28.5% and Pennsylvania tapping into the Marcellus Shale at 16.1%. So, much like those maritime choke points we talked about, our land-based energy production is incredibly centralized.
All right, Section 3, the hidden digital footprint and the massive scale of invisible web tracking.
So we've talked about massive physical infrastructure, but now let's pivot to the digital side. Taking the World Economic Forum's website as a prime everyday example, we see a staggering 371 different data trackers operating continuously in the background. They are there just to monitor and monetize a single visit. Now, out of all those, only 47 are deemed necessary for the site to actually function. But then you have 186 performance trackers silently reporting how you interact with the site, plus another 109 marketing trackers. And those are explicitly designed to track you across the internet, serve up targeted ads, and facilitate real-time bidding for advertisers.
This digital footprint is absolutely vast, and you have these specific entities actively harvesting your data. We're talking about heavy hitters here, places like Google Analytics, Chartbeat, LinkedIn, Quantcast, and Baidu. These trackers are collecting everything: your IP address, your geographical location, exactly which pages you read, how long you stay, even the specific devices you're using. It's this highly sophisticated, completely invisible global system that's just running in parallel to the physical world we just discussed.
Which brings us to Section 4, emerging STEM careers, and exactly who manages these complex systems.
Because really, we have to ask the question, as all these global systems converge and scale, as we rely on these massive energy outputs, while simultaneously navigating an absolute ocean of digital tracking, who is actually out there securing, analyzing, and innovating the tech that runs it all?
Well, the answer is a highly specialized workforce. In fact, STEM occupations are projected to grow more than 3 times faster than non-STEM jobs over the coming decade. As Capital Technology University highlights, the roles with the strongest momentum right now include data scientists, cybersecurity analysts, AI engineers, cloud architects, and renewable energy engineers. These are the professionals designing our intelligent systems, securing our digital infrastructure from the very trackers we just looked at, and driving the global transition to cleaner energy. And as you might expect, the financial demand for this expertise is just immense. Because these roles are so absolutely critical to both the physical and digital economy, titles like senior AI researchers and specialized AI architects are frequently commanding base salaries upwards of $300,000 a year. Basically, when you're the one ensuring that millions of barrels of oil move safely or that massive data sets are leveraged securely, your skills are at an absolute premium.
Finally, Section 5. Blended skills for tomorrow. We're looking at how to merge technical expertise with business strategy.
Because here's the thing, raw technical knowledge just isn't enough on its own anymore. To truly lead, professionals have to bridge disciplines. Yes, you absolutely need the traditional tech skills, the coding in Python or C++, the advanced math, the scientific reasoning, but you have to combine those with a solid business strategy. You need cross-functional management skills and the ability to translate highly technical possibilities into actual commercial viability. You basically have to be the person who can connect the genius research happening in the lab directly to the demands of the global market.
There's this brilliant insight from Capital Technology University that I think perfectly captures the mindset required for this new era. They said, students who thrive will be those who treat their education as a starting point rather than a finish line, and that really hits the nail on the head. Continuous adaptability is the most valuable trait you can have when navigating frontier technologies. The systems we rely on, whether it's a massive energy grid or a cutting-edge AI language model, are evolving so rapidly that lifelong learning isn't just a corporate buzzword anymore. It's an absolute necessity for your career.
So, I'll leave you with this final thought to chew on. As our physical energy grids and our invisible digital data networks increasingly collide and integrate, how are you building the skills needed to secure your place in this rapidly evolving global system? Are you prepared to bridge the disciplines? Thanks so much for joining me for this explainer. I really hope it gave you a fresh, powerful perspective on the hidden forces running our world.